Okay, now we're working on Chapter 19, number 16, another hypothesis test problem. So you can pause the video and read the setup here if you want. But National Committee for Educational Statistics monitors many aspects of education. In 96, 31% of students said their mom went to college. We're going to do a sample, and that sample suggests the rate has gone up to 32. We want to know, is this strong evidence that the rate is actually going up, or is that sample just a fluke? Remember, samples vary. Then if we decide the rate has increased, we're going to decide, is it a significant increase? And again, we use an alpha level of 5%. That's our cutoff. First thing we have to do is define our variable. Let P be the proportion of the population that was successful. Here, population is students. Success is their mom went to college. We have our sample. Remember, X, N, and P hat will always give us 2 out of the 3. Here they give us a sample of 8368 and a success rate, a sample success rate of 32%. So to find X, we multiply and we get this number. But remember, X always has to be a whole number. You can't have 3/4 of a person. So just use normal rounding rules. X will round to 2678. Then we write down our hypotheses. The null hypothesis is what we used to believe, that 31% of students said mom went to college. P equals 0.31. That's our P naught right there. Then the sample says that rate has gone up. Also, the problem says the word increase. Everything says the rate has gone up, so our alternative hypothesis is that P is now greater than 31%. Notice I don't write the 32%. I don't write the sample anywhere here. That sample just tells me whether to write greater than or less than. We draw our picture. Right in the middle is our P naught, 31%. Our sample was 32. We're always going to shade a tail. In this case, we're shading above. Hey, we wrote above. We shaded above. It's not a coincidence. All right, then we'll do the problem on the calculator. So we're going to go stat over to tests, down to number 5, 1 prop z test. We're going to type in our X and our N and our P naught. P naught is this number here, the number we used to believe before we did the sample. Our X is 2678. N was 8368. We chose the greater than alternative hypothesis, so we want to make sure greater than is highlighted here. We hit calculate. There's our P hat. There's our z-score, if we wanted to use a z-score. This is the only number we care about. By the way, notice that that p-value is less than 50%. Look at what I shaded here. You're always going to shade a tail. If you ever get a p-value bigger than 50%, then you pick the wrong greater than or less than. All right, all we care about is this number, the p-value right there, 2%, 2.4% roughly. So there's our p-value, and now we can compare that with our alpha level. This is what we decided ahead of time was strong enough. Anything below 5% is strong evidence. 2% is less than 5%. If the p-value is less than alpha, reject the null and accept the alternative. So now, our final step, we said we're going to accept the alternative hypothesis. We have to write that out. What does this line right here say? It's that we have strong evidence that more than 31% of students said mom went to college. That's this line right here is our alternative hypothesis. That's what this says in words. Then there's this follow-up question. Is this a significant change? So the rate used to be 31. We are now pretty sure that the rate has gone up. We don't know what it went up to. The sample suggests 32, but that's just a sample. But we're pretty sure it's not 31 anymore. So do we think the rate went up significantly? Well, the sample suggests it only went up possibly around 32%. That's not really much of a change. So I would say no, this does not seem to be a significant change. The old rate's 31, the sample now says it's probably around 32. Okay, that's the end of the problem. All the rest of this is just extra information to help you understand. That p-value we got there, that's not the probability of the null being true or false. That's the probability of getting that sample we got if the null was true. So if the rate is still 31%, if nothing has changed, and you go out and do 1,000 samples, 2% of your samples would look like the one we got. Have like a 32% success rate. So either that was a strange sample, or the original assumption was wrong. The original assumption was that 31% of moms went to college. So either we got a weird sample or the rate has changed. So now, just for fun, we think the new rate is around 32%. Let's narrow that down a bit. Let's do a 90% confidence interval. We've already rejected the null. We know the rate's not 31, or we're pretty sure the rate's no longer 31. Let's build a confidence interval around the sample. So we'll go stat, over to tests, and then go to A. One prop interval. Hey, look, it kept my numbers. I'm doing a 90% though. So we'll change this to 90. Hit calculate. And we get this interval. So now we are 90% sure. I need to fix this. This should say we are 90% confident that the new rate is in between these two numbers. That between 31.2 and 32.9 of students have mom that went to college. Notice 31 is not in that interval. We said up here we're pretty sure 31 is not the rate anymore. Well, look, our interval says we're 90% sure that the rate's in between here and here. 31 is not in that interval.